Welcome to the video lecture on buoyancy and Archimedes' principle. We'll look through this really quickly and then draw some free body diagrams in class, which I know are just your absolute favorite thing to do. This follows in section 11.6 in your textbook. We're going to look at the concept a little bit first, and then we'll come back to the principle behind it. When some object is placed in a fluid, it displaces a certain amount of that fluid. That fluid, therefore, applies a force on that object. The force applied, or the buoyant force, is equal to the weight of the fluid displaced. So depending on how much fluid is pushed out of the way, that equals to the amount of force, generally, and in this case, it's always going to be upward, on the object. Where does the buoyant force come from? If we look at a column of fluid, in this case, let's just call this fluid water. We have a column of water here, a box, to make it easy. There's a pressure exerted on the top of the box, and there's a pressure exerted on the bottom of the box due to the liquid around it, the other fluid around it. That box has some weight, has some set mass, depends on the volume. We'll come back to that in a second. The pressure on the top is less than the pressure exerted from the bottom. So P1 is less than P2. This is just kind of straightforward because there's less fluid on the top than there's going to be on the bottom. And there's going to be less pressure generated on the top than on the bottom. The areas are both the same. So force, the buoyant force, is going to be the difference between those two pressures divided by the area. So there we have the buoyant force is equal to the change in pressure, P2 minus P1, times the area. Because remember, change in pressure is equal to force over area. By setting up this change in pressure using what's known as the pressure increment, which we'll come back to when we look at section 11.3, that says the density of the fluid inside this volume times the gravity times the acceleration due to gravity, and the height of this column, or the height between the two different pressures, is going to give us the weight of the fluid displaced, because height times area gives us volume. So the weight, so that's volume times density, which equals mass, times the acceleration due to gravity. This here is the weight of the fluid. The rho GH is the pressure increment. This is a very important thing to know. So rho GH is the pressure increment. It's the amount that the pressure changes due to the density of the fluid and the height between the 2 points that you are looking at. Once again, the pressure increment, rho, times the acceleration due to gravity, times the height, that's the density, times the acceleration due to gravity, times the height of that, is a very important concept. The center of buoyancy depends on the shape of the object and is very important when it comes to ships. Boats really need to have the center of buoyancy directly above their center of mass. This is because if it is below the center of mass and the boat somehow becomes off, tilts a little bit, that's going to create a torque. The center of mass is going to have is going to direct a force downward due to its weight, and the buoyancy force is going to be directed upward, and it's going to actually spin the boat. So this happens right here as an example of a tanker that had the center of mass above the center of buoyancy. And here we have all the containers spilled into the ocean and big, gigantic disaster. So just think about that as we move forward with some free body diagrams. Which has a greater buoyant force when pushed underwater? A 1 meter cube lead block or a 1 meter cube wood block? 1 meter cube is the volume, so they both have the same volume. What if the wood is allowed to float? Which block would have the greater buoyant force now? In this case, if you need some help going through this, please take a moment. I have a link here at the bottom to a simulation, which we'll be using a little bit more next week also, and just kind of go around and play around with the different blocks. In this case, please make sure both of the blocks there for the PhET simulation are set to the same volume. So take a moment, go through there, kind of play around with that online thing, and make sure to answer both of these questions online and put in a solid answer with an explanation. All right? Thank you very much.